Good morning. My name is Iván José Mestre Fernández, and I will be presenting the paper Implementation of the System for Collecting and Analyzing Public and Open Access Information from Brazilian Federal Legislative Houses. Political corruption is a global problem that has affected almost every country in the world, developed or underdeveloped, throughout history. In recent times, due to the media globalization and the emergence of social networks, political corruption scandals in various parts of the world have become events of people's daily life. In the specific case of Brazil, in recent years, major corruption scandals have arisen that have completely shaken the national political environment. These scandals gave rise to gigantic investigations that cover all levels of Brazilian politics. Examples of these scandals are the Mendes scandal and Operation Lava Jato. Corruption has been mentioned as one of the main factors that triggered the 2013 protests across the country. In 2019's Corruption Perception Index published by the non-governmental organization Transparency International, Brazil ranked in position 106, tied with countries such as Egypt, Albania, and Algeria. For all these reasons, it is necessary to develop technological tools that allow citizens to obtain factual knowledge based on real data about the main members and the functioning of the government. For example, it is necessary to have ways to track donations made to political election campaigns and the relationship these donations have to subsequent actions taken by the politicians. It was decided to implement a system that will collect information freely available on the web about politicians. For the creation of such system, it will be necessary to use various information retrieval and analysis techniques, mainly regards to web data mining and web data analytics. Web data mining can be defined as a complex process that includes analyzing a wide variety of information, such as the content and structure of web documents, which can be in HTML or XML, text files, databases, user access logs, reference logs from other servers, user profiles, among many others, for the purpose of finding useful and relevant information, as well as finding new knowledge that will serve a user's needs and the decision-making process. Web data mining mainly deals with the following problems: finding relevant information in large amounts of data, extracting potentially useful new knowledge from large amounts of data, customizing the presentation of content and information for different users, and understanding the actions and desires of users and consumers. The web data mining process is very similar to the traditional data mining process, which is composed of the following steps: gather resources from the web to which the data mining process will be carried out, perform the process of extracting the specific information found in the web documents and discard non-relevant information, extract the patterns of interest, trends, and new knowledge from information repositories. This can be achieved using supervised and unsupervised data mining techniques, and finally validate and interpret the patterns found in the previous phase. Depending on the data used to feed the web data mining process, it can be classified into three main areas of interest: content mining, which is the process for retrieving useful information from the content of web pages and documents. In this process, web mining techniques are applied directly to the content of pages or websites, whether text, images, videos, etc. Structure mining, which is the process of discovering information about the structure of the web using the hyperlinks that connect the different pages and websites. And users mining, which is the process of retrieving useful information about users' browsing and access patterns on pages and websites using access logs. We're going to be focusing on web content mining because it is the area that has more relevance to our work. Web content mining can be defined as the process of extracting useful information and new knowledge from content on pages and sites available on the World Wide Web. These pages usually contain objects with the content in different formats, such as text, images, audio, or video. Nonetheless, generally, web content mining focuses on exploring, transforming, and extracting information from text objects. This is because exploring, transforming, and extracting information from objects such as images, audios, or video is a non-trivial task. The web content mining process generally addresses four major tasks, which are extraction of specific information from the content of web documents and pages, grouping web documents according to the similarity of their content, categorizing web documents into predefined categories, and performing sentiment analysis or opinion mining into user-generated content such as blogs, forums, and social media posts. In order to solve the problems presented above, it is first necessary to implement an information retrieval system that satisfies the requirements to feed the mining and analysis process. This system, currently under development, is called L5P and uses several of the techniques for retrieving and analyzing information described above. The first step was to identify and select the open data sources that will be used to collect data from. These sources are the Cámara de los Diputados website and the Senado Federal website. Both of these websites have information about the congressmen and the senators, their political trajectory, and their legislative performance, such as voting records, expenditure data, and public speeches. La divulgación de candidaturas e contas del Tribunal Superior Electoral website, which has information about the elections and their candidates. The prestación de contas del Tribunal Superior Electoral website, which has information about the campaigns and the campaigns donations. The Portal Brasilero de Dados Abiertos website, which has a wide variety of information about the functioning of the government, and the Meu Congreso Nacional website and Atlas Político, which are two private websites that have complementary information to official sources. Several strategies were developed for the data collection step. Some of these websites provide web services and APIs in different formats such as JSON and XML. So we implemented customized functions for collecting and structuring this data. Also, donation expense information was available in CSV spreadsheets. So we implemented custom methods to download and process these spreadsheets. And finally, we implemented custom crawlers to extract information directly from the content of the websites. After the data is collected, we can begin the data structuring step. The data was classified into 7 entities. These entities and their relationships allow us to represent any object in the known world. These entities are natural person, which represents the congressmen, senators, and the donors that are natural persons. Legal entity, which represents the donors that are legal entities. Social fact, which is an event that occurs, such as an election or a donation. Act, which is a document that contains any of the other entities, such as the spreadsheets that contain the donations data. Place, which represents the states, cities, and towns of Brazil. Measure, that can be used to represent a measure such as a currency. And a thing, which represents any information that cannot be classified into any of the other entities. After the data has been structured, we can begin the visualization step. Here we will present several screenshots of the system showing the information collected. This first screenshot shows the general data of the politician, in this case a federal congressman. Here we can see some personal data and some political data. This screenshot shows all of the campaign donations data received during the 2014 campaign. This screenshot shows how the campaign donations data was then divided into type of donor, whether they're natural persons or legal entities, and then the percentage that each type represents from the total was calculated. This screenshot shows expenditure data during the congressman's term. The expenditure data was also divided by type. Finally, this screenshot shows the relationship map between the congressman and his 10 biggest campaign donors. After finishing this work, some elements can be identified for future developments. These elements are implementing text mining techniques that will allow to analyze the speeches and public statements of a politician. Implement sentiment analysis techniques to analyze the statements and publications of social networks and compare these statements with the actions of the politicians. To create several visualization methods, such as graphs, relationship maps, etc., that will capture the user's attention and will facilitate the understanding of the data. And the implementation of web users mining techniques to analyze the user interactions with our system and customize the tool to the user's needs. Thank you very much for your attention.